All right, guys. I'm going to go back to the anti-differentiation by the U substitution. This should be, I believe, page 601. Just to go back, I don't know if we finished this whole thing, so I just want to double check um, with you this U substitution. And I got like two more uh, after this, and then we'll start our review process. So this is U substitution. So here we have here are some examples of the integral of f prime g of x times g prime of x, which means that the derivative is inside. So this g prime does not always exist, and therefore it's not attainable by multiplying something. So take a look at this equation here, x times 2x minus 1 cubed dx. The inner function here is your 2x minus 1. What would be its derivative? The derivative of 2x minus 1 is just 2. Is this 2 part of this integration? So forget this. What's left? I got the x and the dx. Is 2 part of this integration? The answer to that is no. Can I get this g prime by multiplying something here? Which means, can I multiply this by something to get to the 2? The answer to that is no. Why? Well, because what do we have left is x. In order to, excuse me, in order to get x, in order to get 2, I'm going to multiply x by 2 over x. So that gives me my 2, because we're looking at this 2 back in here. So this part right here is not a constant. So remember, you have to multiply by some number, but since that's not a constant, the answer to that is no. All right, so let's see what we can do then. First, let's identify the inner function for this problem. We're going to say let u be 2x minus 1. Find its derivative. Derivative of u is du over dx is 2. But I always want to just get rid of this dx. So from now on, when you take the derivative, we're just going to say du. We'll take the derivative, and then we're going to tag along that dx right here. Step 3, find expression of x in terms of u. What that means is from your u function here, which is 2x minus 1, find expression for x. That means solve this thing for x. So to solve this guy for x, I'm going to add 1. And then I'm going to divide that by 2. Okay. So now let's talk about our integral right here. The integral of x, 2x minus 1 cubed dx. All right. I'm going to rewrite this. The integral, x becomes u plus 1 over 2. The 2x minus 1, in parentheses, that's my u, to the third power. And I need to solve for dx, don't I? So back here, oh, I forgot in part 2, it says in solve an equation for dx. To solve for dx, it's du over 2. So dx becomes du over 2, or 1/2 du. So what I'm going to do is this. I'm going to take this half from here. Hold on, let me rewrite this as 1/2 u plus 1 u cubed 1/2 du. I'm going to take this half and this half, which is a fourth, bring it on the outside. And then I have u plus 1 u cubed. So I'm going to put it like this, du. So what we're going to do here next is we are going to distribute this u cubed to the u plus 1. And then we're just going to do our integration from there. We end up with u to the 4th plus u cubed du. Okay, so that gives us 1/4 The integral of u to the fourth is u to the fifth over 5. The integral of u cubed is u to the fourth over 4. Don't forget your constant of integration. Now I'm going to distribute this 1/4 throughout, and I end up with, let's see, 1/20th u to the fifth plus 1/16th u to the fourth plus 1/4 times c is just some c, and now I'm going to plug back what u is. So this is 1/20th 2x minus 1 to the fifth plus 1/16 2x minus 1 to the fourth plus c. Okay. So that takes care of this page. The next page, oops, sorry. There we go. We have this equation right here. 2x plus 1 over the square root of x plus 4 dx. So one way to rewrite this, I'm going to keep the 2x plus 1. I'm going to take this square root of x plus 4, which is x plus 4 to the 1/2, bring it to the top, becomes x plus 4 to the negative 1/2 dx. Okay, so what is our u? Our inner function u is x plus 4. Usually 98% of the time is the one with the power. Take its derivative. Du, the derivative of x plus 4 is just 1, because the derivative of x is 1, but I have to tag along that dx. Solve for dx. Dx is solved for. Solve this thing for x. So u is equal to x plus 4. U minus 4 is equal to x. So let's rewrite this guy. So you have your 2x plus 1, your x plus 4, that's your u, to the negative 1/2, and dx is du. Okay, now I'm left with this 2x plus 1. I got two different variables. I got x's and u's. Can't have that. So I have to rewrite this. Well, we solve for x. X is u minus 4. So this is the integral of 2 times u minus 4 plus 1 times u to the negative 1/2 du. All right, if I do this inside, I get 2u minus 8 plus 1 is minus 7. So I got the integral of 2u minus 7 times u to the negative 1/2 du. Now, if I distribute this u to the negative 1/2, I end up with the integral of 2u to the 1/2 minus 7u to the negative 1/2 du. And now I'm going to integrate u to the 1/2. Its integral is u to the 3/2. So u, that's 2u to the 3/2 divided by 3/2 minus 7u to the 1/2 divided by 1/2 and plus c. Fixing this up, I get 4/3 u to the 3/2 minus 14 u to the 1/2 plus c. Well, I know what u is. U is x plus 4. So we end up with 4/3 x plus 4 to the 3/2 minus 14 x plus 4 to the 1/2 plus c. Okay. And then finally, we have a limit here. Same thing. So I'm going to start here. Let u be your 2x plus 1, because that's the inside right here. Du is 2 dx. Solving for dx, divide by 2, 1/2 du is equal to dx. Okay. From up above, let u equals that. So if u is equal to 2x plus 1, u minus 1 over 2 is equal to x. Okay, so here we end up with from 0 to 4. I'm rewriting. What is x? X is u minus, so I'm going to do 1/2 u minus 1. This is u to the 1/2, and dx is 1/2 du. So I end up with this 1/4 right here. U to the 1/2, u minus 1 du. Now we have two options. You see these limits? We can change limits. 0 to 4 is for the variable x. If you want to keep it with u's, then we have to change from 0 to 4. What does that mean? We solved for what u is. Let me go down here. U is 2x plus 1. If x was 0, when x is 0, u is equal to 1, because plug in 2. And if x was 4, u is equal to 9. So if I want to keep things in u terms, then my limits is not no longer from 0 to 4, now it's from 1 to 9. I mean, you can do this process. If not, you can go back and change, like here, we change the u's to the x's, and we can keep it from 0 to 4. But I'm going to keep it in the u term because sometimes it'll be easier. Let me distribute this. So I got 1/4, the integral from 1 to 9. We end up with u to the 5/2 minus u to the 1/2 du. Okay. Let's see. I'm sorry, not 5/2. That's 2 over 2. That's 3/2. Not 5. That's 3. Okay. When I integrate it, I get u to the 5/2 over 5/2 minus u to the 3/2 over 3/2. And we are going to evaluate from 1 to 9. Okay, so let me tidy this up. We got 1/4, 2/5 u to the 5/2 minus 2/3 u to the 3/2 from 1 to 9. As you see, now I can plug in 9 minus 1 because these are in terms of u's. If I didn't do from 1 to 9, kept it from 0 to 4, I would have to rewrite what u is, which is 2x plus 1. Well, so this gives me evaluate at 9 and minus at 1. So we have 1/4. We have 2/5 times 9 to the 5/2 minus 2/3 9 to the 3/2 minus 2/5 1 to the 5/2 minus 2/3 1 to the 3/2. So it's 1/4 times this whole thing. This should be like a big parentheses right here. Well, you can do the math from here, and I get 1/4. I'm going to end up with 2/5 times 3 to the 5th minus 18 plus 4/15, and that's approximately 19.867. Okay, so this is the U substitution. Do the following homework assignment. I would like you to do these following problems. This is your homework. I want you, number 1, integrate x cubed sine of x to the 4th dx. I want you to integrate x cubed over 1 plus x to the 4th squared dx. I want you to integrate 5x square root of 1 minus x squared dx. I also want you to do integrate x plus 1 square root of 2 minus x. And finally, integrate from 1 to 5 x over square root of 2x minus 1 dx. So this is the homework assignment that I would like you to submit via Google Classroom.